Hi there, science fans. Today we're talking about a super cool technique called X-ray diffraction, or XRD for short. XRD allows us to peek inside materials and see their hidden structure. It's like having X-ray vision for scientists. XRD is a big deal in the world of material science. It helps us understand how materials are put together at the atomic level. This knowledge is crucial for developing new materials with amazing properties. Think of things like stronger airplanes, faster computers, and even life-saving medicines. XRD is like a powerful detective tool. It helps us identify unknown materials and figure out what they're made of. It also tells us about the size, shape, and arrangement of tiny crystals within a material. Pretty neat, huh? So, how does XRD work? Well, it all starts with X-rays. X-rays are a type of electromagnetic radiation with very short wavelengths. When these X-rays hit a material, they interact with the atoms inside. Imagine the atoms in a material are like tiny dancers arranged in a specific pattern. When the X-rays hit these dancers, they scatter in different directions. This scattering is not random though. It depends on the arrangement of the atoms in the material. The way the X-rays scatter is called diffraction. By measuring the angles and intensity of the scattered X-rays, we can figure out the arrangement of the atoms in the material. It's like reconstructing a dance routine just by watching how the dancers move. The arrangement of atoms in a material is called its phase structure. This intricate arrangement determines many of the material's properties and behaviors. Just like our fingerprints are unique to each of us, providing a way to identify individuals, every material has a unique phase structure. This uniqueness acts like a fingerprint for the material, allowing scientists to identify and differentiate between them. X-ray diffraction, or XRD, helps us identify these fingerprints and tell different materials apart. By analyzing how X-rays scatter off a material, we can determine its atomic structure. Think about diamond and graphite. Both are fascinating examples of how the same element can form vastly different materials. Both are made of pure carbon, but they have very different properties. This difference is due to the distinct ways their atoms are arranged. Diamond is super hard, making it ideal for cutting tools and jewelry, while graphite is soft and slippery, perfect for use in pencils and as a lubricant. Why? Because their atoms are arranged differently. In diamond, each carbon atom is bonded to 4 others in a strong three-dimensional network. In graphite, carbon atoms form layers that can slide over each other easily. XRD can easily distinguish between diamond and graphite based on their unique diffraction patterns. These patterns act like a signature, revealing the material's internal structure. Knowing the phase structure of a material is essential for understanding its properties. This knowledge is crucial in fields ranging from materials science to engineering. This knowledge helps scientists design new materials with specific characteristics for various applications. By manipulating atomic arrangements, we can create materials with desired properties. For example, we can use XRD to study the structure of metals used in airplanes to make them stronger and lighter. This ensures better performance and safety in aerospace engineering. Now let's meet the star of the show, the XRD machine. Don't worry, it doesn't bite. An XRD machine is like a sophisticated camera that takes pictures of materials using X-rays instead of visible light. The basic components of an XRD machine include X-ray source. This part generates the X-rays. Sample holder. This is where we place our material sample. Detector. This component measures the intensity of the scattered X-rays. Computer. This is the brain of the operation, controlling the experiment and analyzing the data. XRD machines come in different shapes and sizes. Some are small and portable, while others are large and complex. But they all work on the same principle of X-ray diffraction. Section 5. Prepping your sample, getting ready for the X-ray show. Before we can start our XRD experiment, we need to prepare our sample. We want our material to be in a fine powder form. This ensures that the X-rays can interact with as many crystals as possible. Think of it like this. If our material is a big chunk, the X-rays might only see the surface. But if it's a powder, the X-rays can see all the different angles and facets of the crystals. Once we have our powder, we carefully load it into a special holder. This holder ensures that the sample is positioned correctly in the XRD machine. We don't want our sample to move during the experiment. Section 6: Lights, Camera, Diffraction, running the XRD experiment. Today, we dive into the fascinating world of X-ray diffraction, or XRD for short. This powerful technique allows us to peer into the atomic structure of materials, revealing their secrets. With our sample prepped and loaded, it's time to run the XRD experiment. The preparation phase is crucial, ensuring that our sample is clean and properly mounted. We carefully place the sample holder into the XRD machine and close the door. Safety first. This step is essential to protect both the sample and ourselves from any potential hazards. We don't want any stray X-rays escaping. X-rays can be harmful, so we follow strict safety protocols to ensure a safe working environment. Now for the exciting part. The anticipation builds as we prepare to uncover the hidden patterns within our sample. We turn on the X-ray source and aim the X-ray beam at our sample. This is where the magic happens, as the X-rays penetrate the material. The X-rays interact with the atoms in the material and scatter in different directions. This scattering creates a unique fingerprint for each material. The detector picks up these scattered X-rays and measures their intensity. The data collected will help us understand the material's structure. The XRD machine collects data for a specific amount of time, usually a few minutes to a few hours, depending on the material and the desired resolution. Patience is key here, as the quality of the data depends on the duration of the experiment. While the experiment is running, we can monitor the data in real time on the computer screen. How cool is that? This real-time monitoring allows us to make adjustments if needed and ensures that everything is running smoothly. The data we gather will provide invaluable insights into the material's properties and potential applications. Section 7: Decoding the patterns. What's the story, XRD? After the XRD experiment is complete, we get a graph called a diffraction pattern. This pattern shows the intensity of the scattered X-rays as a function of the diffraction angle. It might look like a bunch of peaks and valleys, but it's actually packed with information. Remember those unique fingerprints we talked about earlier? Well, the diffraction pattern is like the fingerprint of our material. By analyzing the position, shape, and intensity of the peaks in the pattern, we can identify the material and determine its phase structure. To decode these patterns, scientists use special software and databases. These tools help us match the experimental data with known diffraction patterns and figure out the identity and structure of our material. Section 8: XRD in action, from medicine to microchips. X-ray diffraction, or XRD, is a powerful technique that has revolutionized the way we understand and manipulate materials. XRD is like a Swiss Army knife for materials scientists. It offers a versatile and comprehensive approach to analyzing the atomic and molecular structure of various substances. It has a wide range of applications in various fields, including, but not limited to, medicine. XRD helps us study the structure of bones and teeth, providing insights into their composition and health. It also plays a crucial role in developing new drug delivery systems, ensuring that medications are delivered effectively to the right parts of the body. And even analyze kidney stones. By understanding their composition, we can develop better treatments and preventive measures. Pharmaceuticals, or XRD, is crucial for identifying and characterizing drug compounds, which is essential for the development of new medications. It ensures the purity and stability of medications, making sure they're safe and effective for patient use. Geology. Geologists use XRD to identify minerals, study rock formations, and understand the history of our planet. This helps us learn more about Earth's past and predict future geological events. By analyzing rock samples, scientists can uncover the secrets of Earth's formation and evolution. Material science. XRD helps us develop new materials with improved properties for applications in electronics, aerospace, and energy. This leads to the creation of more efficient and durable products. These are just a few examples of how XRD is used in the real world. Its applications are vast and varied, touching almost every aspect of modern science and technology. From developing new technologies to solving scientific mysteries, XRD provides the tools and insights needed to push the boundaries of what is possible. XRD is an indispensable tool for scientists across many disciplines. Its ability to reveal the hidden structures of materials makes it a cornerstone of modern scientific research and innovation. Section 9: XRD, a superpower for scientists. Learning about XRD is like gaining a superpower. It allows us to see the unseen, understand the complex, and create the extraordinary. Whether you're a seasoned scientist or just starting your scientific journey, XRD offers a world of possibilities. XRD is not just about collecting data, it's about asking questions, solving problems, and pushing the boundaries of knowledge. It's a tool that empowers us to make new discoveries and contribute to our understanding of the world around us. So, if you're curious about the hidden structures of materials and want to be at the forefront of scientific exploration, XRD is the key. Section 10. Keep exploring XRD. The adventure continues. Congratulations on taking your first steps into the fascinating world of XRD. This is just the beginning of an exciting journey. There's so much more to learn and explore. There are many resources available to help you dive deeper into XRD, from textbooks and scientific articles to online courses and workshops. Don't be afraid to ask questions, experiment, and have fun. Remember, science is all about curiosity, exploration, and discovery. So, go out there, unlock the secrets of materials with XRD, and who knows what amazing things you might find.